Hello everyone. In today's webinar, we are going to talk about most common ways to mess up your vibration test and all kinds of ways to prevent this. We are hoping to make it interesting and worthwhile. In this webinar, we're going to discuss common errors during the shaker setup, during the sensor setup. I'll show you some ways of overloading the shaker. We will talk about fixture methods and discuss other common issues. So let's start. Number one rated service situation can happen during wrong shaker setup. Before your vibration test, you need to pay attention to the shaker settings. First of all, your shaker must be serviceable. And the main thing you should remember is that you should really carefully enter your shaker parameters in our software. Here in the screen, you can see the shaker settings window. Here we have our regular shaker, and all these parameters are entered according to the shaker's passport. But I must say that we have only one important thing. In our software, we set displacement as 0 peak, not in peak. Here you can see it. It's outlined with red. And the most common mistake when people don't read our manual and enter this value in peak. That means that the maximum displacement value is twice higher when the limit value according to the passport. In that case, you can damage your shaker. And personally, I recommend to double check the shaker settings before the test. Here in our software, we have configuration tab, and here we have our shaker database. And for example, in this shaker, you need to enter its frequency range, its maximum limit values, and here you see the 0 peak displacement. We need to enter these values for sine, random, and shock tests. We count them as the basic parameters. Let's go back to our presentation. And the most common errors during the shaker setup, as I mentioned earlier, can be wrong shaker settings, wrong limits, and we have another option which must be checked all the time. It's called check for shakers limits option. I will show you it in our software. For example, we need to run sine test. Let's create a new one. And here in the profile tab, we have two checkboxes: check for shaker limits and check for profile on the fly. This option is really important because it checks your profile and its limit values comparing to the shaker limits. For example, if our limit value for acceleration for the shaker is 5G and we enter the maximum value for the profile as 10G, this function will stop us from starting such test. For example, let's set our start frequency at 10 Hz, start amplitude will be 1G, and frequency will be 200 Hz. And here in the end amplitude, let's enter 300G. And here we apply, and you see that the maximum profile acceleration for this profile exceeds the shaker limit, and you won't be able to run such test. Check the profile on the fly function helps us to do this check every time you enter a new line of the profile or change the values. I think it's very useful, and you can correct the mistakes during the test setup. So let's close it. And here I need to press cancel. Another interesting option to destroy your shaker is shaker overloading. Here you see a picture with a shaker and it has loaded mass on its table. Every shaker has its maximum object mass, and during the test I recommend to enter its value in the software and not to exceed the maximum limit of the mass. For example, here in the shaker settings we have masses, and here we have the maximum moving mass and the maximum object mass. It is set in kilos. For this shaker, if you exceed this value of 500 grams, you won't be able to run such tests, and you may damage your shaker. In our settings, we have a special tab which is called limits, and here you can set all kind of masses for the test, like object mass, mass of the fixture, mass of the shaker's table, and other mass which will be included into calculations. You should be very careful with this parameter because it can easily damage your shaker. So
yeah, before we move on, can I just add about the previous one, about the check for shaker limits in our software? Can you show the function again?
yes.
Yeah, I just wanted to add here that even if the box is not checked, which we don't recommend, the warning message will still appear. So there will still be a message. Are you sure you want to start the test without the check for limit checkbox? Because it's dangerous for your shaker. So yeah, we try to double check that you do it, understanding the consequences, the possible consequences. Yeah, I'm sorry.
And I need to mention that if you disable this feature, you'll see this message again on during the starting the test when you press the start button. So we try to protect our users from destroying the equipment. Let's go. Another way to mess up with your vibration test is shaker fixture. Here in the screen you can see multiple ways of shaker fixture with the stud, wax mounting, magnetic, and using electrical isolation base. You should select the most appropriate method for your setup. For example, if you have a lone object and it doesn't have any place for the studs or some magnets, you should use wax mounting, or in some kind of test we recommend to use glue. If you fix your sensor badly, it may have wrong signal, you may have some noises, and you won't be able to run your test correctly. So you should double check the fixture before you start the test. Also, I should mention that you must double check the connection of the sensors and check if the cable is okay, because we had some troubles when our user fixed the sensor, but he didn't check the cable and the cable was broken and he had some issues. So another interesting feature I should say that we need to double check our sensor configuration. Here in configuration tab we go to channels, and here you see all available channels for our system. They have their sensitivity, its units, and its type. The most common way to destroy your shaker is to wrongly set the sensor type. For example, I have an accelerometer which has IPE type, and you set its type as linear. In that case, our controller will get the signal from the sensor but it will be really low, and the system will try to start up and increase the signal, and in that case you can damage your equipment. You must remember that you need to double check the sensors before the test, and it's very important during some shock tests when you have a lot of IP sensors, but you for some way set one of them which is used for controlling the setup as linear, and the system will make really strong shocks. It can damage all your system. And I should mention that in our software we check voltage to acceleration limits, and if you exceed this limit during the test, the system will stop automatically and you'll see a message. So now we can continue. Another way of fixture you should know is the shaker fixture. For example, I'll show you the camera now. Here you can see that we have our shaker, and on its stand you see 4 holes. They are made for using the rubber rest, for example, like shown in this picture. On the third picture you can see that we fixed this shaker on the special stand. This setup is used when we run multi-shaker tests. For example, we have a long stand with multiple shakers on it, and we run this test on one vertical axis. So we need to fix all our shakers on this stand. Also, we recommend to use some rubber mats for the shakers, because we had one shaker destroyed when we didn't fix our equipment properly, so it just fell down from the table because of the vibration. And you must be really careful with the shaker fixture, and I recommend to hardly fix the shake on the surface. And now let's talk about the most common issues we have. First of all, you need to check the grounding. On our devices, we have a special ground screw, and it's used for removing 50 Hz noise from the sockets. And this grounding is really important because in some ways you may damage your shaker, and this issue is connected with the second one. We recommend to set the amplifier gain knob to 0 when the test is stopped, or you turn off your setup. For example, you have a turned on amplifier, it has some gain, and you get the 50 Hz noise, and as a result, the shaker table is moving, and for example, the level is rather high, and you can damage your shaker that way. Also, this 50 Hz noise will mess up your calculations, and it will start up a bit longer. So personally, I recommend to use ground screw for this way of grounding. I think also I should mention that in some ways shakers have the cooling system. Sorry. Here you see that in the first picture we can see a water cooling shaker, and it's very important to set up the cooling system properly for the test. If you don't use it, you will overheat your equipment and get some troubles. In our software, we have the emergency stop and feedback options. Here, in the left side on the control panel, we have emergency stop and feedback checkboxes. I recommend to enable them during the test, and emergency stop is enabled automatically. This option means that if you get some kind of issues during the test, our system will analyze the incoming data, and if we exceed some limits, get some troubles with the controller or some kind of other stuff, it will cut off the signal and stop the test automatically. So I recommend to enable these features all the time. During the multi-shaker tests, you need to double check the connection according to your software settings. I'll show you an example here. I think let's show you a multi-shaker sign example. We have some test, and here we have our control loops. And here you see that our first output is connected with the first channel, and our second output is connected with the second channel. That means that you must be very careful connecting these channels. For example, if I, by my mistake, connect first output with the second channel and second output with the first channel, I'll get my profile by both channels. The system will try to start up, but the calculations will be wrong, and our system will try to start up, and in the end it will stop automatically because it will take a lot of time, and the system will stop this starting up process. So I recommend to double check control loops, all kind of channels connection, and you must be really careful with the sensor types. Also in our software we have two important options. One of them is called pre-start check, and we have a diagnostics window. Here, let's go back to regular sign. Here in the main tab, you see the diagnostics button, you press it, and here you see the oscilloscope. On the right side, you see the voltage value, the frequency, and the start button. You set values as you wish and press start. In that case, your system will generate the signal, and on the oscilloscope, you'll see the data. You can change outputs here and see if all sensors or outputs are working properly. Also, we have a spectrograph option, and if you don't know what's your problem, you should open diagnostics window and double check all your channels outputs using this feature. Another option is called pre-start check. You need to set it at default settings here, and it's set in first start window. Here I'll skip a bit. Here you see the start check option. That means that before the test start, you'll see a window with all kind of test parameters, sensors data, sensors types, the profile, all kind of limits, and this window will remind you of some kind of stuff during the test, and in that way you will double check your parameters. So I recommend to turn on this feature. Also, during some kind of shock tests, random tests, you may have some kind of an object which has resonances at high amplitudes and high frequencies. For example, we have a lone object, we have 3 sensors, and one of them cannot run at higher than 3G amplitude. In that case, go to Limits tab here and see Notch Limits. Here you see all the channels of your system, and you can set here inside the lower limit and the upper limit. If one of the control channels or other kind of monitoring channels will go higher or lower than your limit, the system will decrease the signal and try to run at a lower level. For example, we have a random test with a maximum acceleration of 5G, but we need to set the higher limit of 3G for one of the channels. And when we run the test, we suddenly get, for example, 4G on our notching channel, and the output signal of the system will go lower until we reach our limit value. It's a very important feature, and I widely use this during my vibration tests. And the biggest advice for you is to select shaker and sensors according to the test specifications. For example, if you have some kind of shock, SRS or TTH test, you should use a special shock test shaker. But if you know, for example, if you are running at higher frequencies, you should get a high frequency shaker, or you should use some special calibration shakers if you're running some calibration tests. So you should be really careful with your equipment and double check it and set your configuration according to the test and task specifications. I think that's all information I wanted to say about the common issues. If you have some questions, you should ask them and I'll try to answer. And if your question is rather tricky, you can write on this email and we'll try to help.
Yeah, okay. Thank you, Philip. I think we have a couple of questions here. First, what would happen if a sensor cable is broken during the test?
If the sensor cable is broken, I think the voltage to acceleration value, which is being checked during all the tests, will work, and you'll get an emergency stop. So I get such results during some kind of tests, and in that case, the test will stop automatically.
So an emergency stop or a warning?
You'll get an emergency stop.
An emergency stop, okay. What do you recommend in case there is a resonance during shock test?
I think during the shock test, we have a special feature called filter. Let me show you in our software. Here, let's go to test settings. And here in control tab, shock test, we have a filter option. You enable it by clicking use filter. And for example, we know that we get resonance at 20 Hertz. We press use filter. And here we enter our filtering frequencies. So the range now from 0 to 100 Hertz will be filtered.
So basically, for for sign test, if there is a resonance, we can use notching.
Yes.
And for random.
For random, I recommend to use notching. And we have another question here. The question is about mounting the accelerometers when we don't have a space to mount them. You can use some special fixture for your setup.
So I'm sorry, the question is, let me just read the full question. What do you recommend in case when there, oh no, that's not that question. Sorry. What should we do if there is no space to mount accelerometer to the shaker directly? Is it okay to mount it on the object under test or fixture?
Yes, you can mount control accelerometer on the object, but if you have such issue, I recommend to write us, and we will try to help you and make you some advices. But if it's not possible, then please set the shaker close to the table as possible. Sensor to the shaker's table.
So as close as possible to the shaker
to get the direct signal data.
And there's also a question here connected. What is the best location to mount control accelerometer?
Personally, I recommend to place it in the center of the shaker's table. For example, our shaker, which we regularly use, have a hole for the shaker, a hole for the stud in the center of the shaker's table, and in that case, you'll get the correct data.
So the best location is on the shaker table, right? Okay. Yeah, there is. I think there is another question. We see it. It's about difference between high and low sensitivity. It's a little long to answer right now. I think we can answer in the email because it's more like we could explain it in a few paragraphs of text. So I will follow up, and I will follow up to everyone just in case. The specific application for high sensitivity and low sensitivity, we will explain it then in the follow-up email. So there is still a little time for asking questions. We will wait for a little bit if more questions arrive. Now, just to sum up, to avoid common mistakes, what you check the shakers, check your equipment, check the shaker is set properly, how it's rested, how it's cooled, the sensor is fixed properly, choose the best way to fix sensor for your particular object. Yeah, and in our software, we made sure that there are all sorts of safety checks, and we recommend to apply them all. Maybe it is a little more work that you have to check all the safety boxes and check for shaker limits, but we make sure that your equipment will be safe.
I think we have a question about verifying accelerometer is good or bad. I think in that case you should use calibration option in our software, and here we have a sensor calibration option. Here you set your sensor, all its parameters, and here we can use different modes, and we have a random signal sensor calibration, and in that case it will take about 3 minutes. So that way you can check your sensor if it's working properly.
Yeah, we will not go in full detail of all the settings of sensor calibration, but it is a good way to check your sensor. We have a webinar, we have a video connected to that. We can send you the links to those in the follow-up.
I see a question about how to select sampling frequency. In our software, we have an option which is called auto sample rate. You press it and our software will calculate the proper sample rate for you. And I think in that case, we'll get the best results. Let me check other questions.
And there is the question about strain gauges, if they operate in the same way in force control.
Yes, they are.
So yeah, basically so.
But I should mention that the force control now is only available in sign and fatigue tests.
But in terms of these protections, the operation is the same.
Yeah.
Yeah. Okay.
I think we have a question about showing settings. What do you mean?
No, I mean probably it's about the strain gauges.
And here we have a special button which is called additional strain channel parameters. And here you can connect to strain gauge amplifier, set the parameters, even calibrate.
Yeah, so these are those in short. Yeah, maybe more detail we can answer you and give you the screenshots for that, like directions on how you go about your strain gauges in RULA devices.
And we should mention that there are strain parameters of the amplifier for RLC21 or special channels for RLC25 with the strain gauge module.
If the control signal reaches the alarm limit, do we get any warning?
We'll have a warning in the 15th version and an emergency stop.
Yes.
So
not for now, I guess, but yeah, in the next version we will implement it. Yeah. Yeah, okay. I think that's pretty much it. In terms of your questions, we will make sure that every question is also answered in writing. So in the follow-up, so that you really get all the details, because maybe now it was, a bit fast, our answers. So we will make sure we provide the proper information in the follow-ups. But yeah, but thank you very much for your interest and for a lot of questions. Probably tomorrow you will all receive follow-ups with our own checklists, and we hope we can also answer any additional questions that you might have. If you'd like to get this presentation, the video, please also do let me know after the follow-up. We'll be happy to send it. Thank you so much for joining. We hope that your vibration tests run very smoothly, and we at RULA will try to make sure that we help you get the best of your vibration testing experience. Thank you so much and have a nice day.
Bye.